Alright, we are starting another unit, so buckle up because we're going to get after it. This unit deals a lot with area and surface area and volume and figuring out those sorts of things. And so we get started by doing something that hopefully you remember, and then we will learn hopefully something new along the way as well here. Okay, but hopefully the thing that you remember from whenever that would have been is that the circumference of a circle, there's a certain equation for, and you don't have to have this equation memorized, but hopefully it's something that you're familiar with. Circumference of a circle, which is, remember, circumference just means you travel around the circle once. You're looking for that total distance all the way around. And to figure that out, you can multiply the diameter, which is this full distance, times pi, or more commonly, what we do is we take the radius, which is from the center to the edge, the radius times 2 times pi, 2 pi r, because 2 of these radii is 1 diameter, so that's why 2r and d kind of are interchangeable. The new stuff is going to be over here, and just to kind of, before we get started with that, I'm going to kind of lead off with an example. And let's just say I draw this circle. That's a pretty good circle. Good job, Mr. Kuiper. Okay, and I say that the radius is, let's say, 3. And I want to say, what's the circumference? Well, the circumference of this circle would just be 2 times pi times r. My radius is 3, so this would be 2 times pi times 3, and 2 times 3 is 6, so it would be 6 pi, and that would be the circumference all the way around. Remember, pi is 3.14 such and such, so it would be right around 18, 19, 20 in there if you actually did 6 times pi, but we'll just leave it. My question, though, is what if I didn't want to go all the way around? I only wanted to make it a quarter turn. So I just wanted to know how far, or what's this length right here of this curve? Okay. Well, if I know the whole circumference is 6 pi, and if this right here is just a quarter of the circle, doesn't it make sense to take this 6 pi number and just divide it by 4? Because then it's not the whole circle, it's just this, it's a fourth of the circle what I'm looking for. Okay, and then you can simplify this, and this would become 3 pi over 2, and then whatever that ends up being would be your what we call arc length. This is an arc, and the length of that arc is, well, since it's just a fourth of the entire circle, find the entire circle and divide it by 4. And that is what this formula says right here. Okay, so to find the arc length, first right here, this piece is just the fraction of the circle. How much of the circle are you taking up? And then this 2 pi r, this is the circumference. So this is basically, in terms of this problem, this is circumference times a fourth. If you had half the if you're just looking for half a circle, circumference times a half. So now, hopefully that gives a little bit of perspective of what that equation is saying. Okay, so just do a couple of these examples straightforward. Circumference of a circle with radius 9. Well, circumference is 2 times pi times r. Okay, the radius is 9. 2 times 9 is 18. And you can leave your answer in terms of pi, so 18 pi centimeters. You don't actually have to go through and multiply 18 by pi. You can just leave it as 18 pi. Okay. Example 2 will use this arc length formula right here. So I'm only looking for the length from right here from A to B. And since there's 360 degrees in the circle, it's over there. You're good. That's Avery, by the way. Hi. So since there's 360 degrees in a circle, I only care about this first 60 degree part right here. So if I find the circumference of the whole thing, I can multiply it by that fraction of 60 over 360. I'm just looking for this fractional piece right here, 60 over 360, times 2 times pi times the radius, which is 8. Okay, so that's just a very direct application of this formula. 60 over 360 actually simplifies into a 6. 2 times 8 is 16, so 16 pi. So I'm just looking, the whole circumference is 16 pi, but I'm just looking for a sixth of that. So you can do 16 pi in your calculator and divide it by 6, or you can leave it as 16 pi over 6, which would simplify by taking a 2 out of each of them into 8 pi over 3. And that is in centimeters. Okay. So you don't have to, like I said, you don't have to multiply that through, but just wanted to take you through a couple examples of showing you how to use this formula here. Okay. This lesson is going to really lend itself well to story problems and different applications of that, so we'll do a couple of those here. You have a car tire here, and it's making revolutions as it spins around. Just keep in mind that one revolution is 360 degrees as you go all the way around. To use this formula, you need to know the radius. Okay, it doesn't actually give you the radius here, but what you do is if you add these three things together, that will give you the diameter. So 5.5 plus 15 plus 5.5 is 26. So from top to bottom, it's 26. So if your diameter is 26, then your radius is going to be half of that, which is 13. Okay? So that means that this distance from the center to any point on the circle would be 13. Okay? So now that we know our radius, that's going to be really helpful for us. One trip around, one revolution is just basically the circumference. So if we find the circumference, using the circumference formula of 2 times pi times r. My radius is 13, so I put 13 in place of r. 13 times 2 is 26, so 26 pi is the circumference all the way around. Okay, but we don't want one time all the way around, we want 15 revolutions. So the total that it traveled is not one of these 26 pi's, it's actually 15 26 pi's. One time around is 26 pi. We got 15 of those. So when you multiply that through, you'll get 1,225.2 inches. And if you want to convert that to feet, it's roughly 102 feet. What's up?
Do you have 10.1b math sheet?
I'm gonna have to print you one, but I'm making a video right now. Oh wait, here.
I think.
Yep. So the final answer is this 102 because you're rounding to the nearest foot. Just took this number and divided by 12 to get 102 feet. Okay. All right, we'll do one more example of this, and then we'll move on to 11.2. This one's a little bit tricky, and so this is also a good question. Hint, 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 hint. So what you're trying to ultimately figure out is a runner's going once around the track, and you're going to figure this out. So for you track people, here you go. This is actually accurate. So they are taking the, let's see, 36.8 is this one right here. So we're looking at this one. So we're going to use the 36.8 as our radius. So if you take a look at this, if you're going once around, okay, your total distance that you're traveling, if I just kind of maybe draw these dotted lines in here, if you're going once around the track, you track people already know how long that is. But if you're going once around the track, notice you have two straightaways right here and right here, and then you have two curved parts right here and right here. Okay, so for the straightaways, you have two straightaways plus the two curves. Okay, for the two straightaways, it's just this distance and this distance again. So you're going 2 84.39 meter stretches, right? That just gives you this distance right here. So the straightaways is that distance. But then you're also going on the curves, okay? And you can get into track and the strategy behind running on the curve. And if you know someone in track, then you can ask them. But really what these things are, if you're looking for this distance and this distance, notice that these are just distance of a half circle, right? Half a circle. Half a circle, and actually 2 half circles can just come together to make one full circle. So really a half circle here, half circle here. For our purposes, we're just going to assume that that's one circle. So all the way around one circle is the circumference of circumference equation of 2 pi r, where the radius is 36.8. Okay, and then now you'll solve this, and you can actually just throw all of this into your calculator. 2 times 84.39 plus 2 times pi times 36.8, and you should get very, very, very close to 400 meters, which for you track people, you knew that already. You knew that once around the track is 400 meters. Okay, but that's kind of how you use the equations that we've been talking about. So that is going to end 11.1. We're going to very quickly do 11.2 because it's very, 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 very closely related. The reason it's very closely related is because we're using a different formula but in a very similar context. So the area of a circle equation is pi times radius squared. Once again, hopefully that's something you remember. So you take the radius, you square it, multiply it by pi, and you get your area. So in example 1, if you find the area of a circle with a radius of 2.5, okay, area is equal to pi r squared, and your radius is 2.5. So you do 2.5 squared, and 2.5 squared is 6.25. So what you could do is you could leave your answer like this and just say, oh, 6.25 square centimeters. Since it's area, it's square units. Or if you actually did want to multiply pi through, you would end with 19.63 square centimeters. And either one would be fine. Okay? So hopefully that's something that you remember doing. This is not an equation that you have to have memorized, but it will be given to you. Take your radius, square it, multiply it by pi, and you got your answer. Okay? What we're looking at now is not necessarily the length of this arc length right here. What I'm actually looking for is if I can solve for the area of a circle, all of this stuff in the middle. I don't want all of that stuff. I just want this portion of the pi. Okay, so it's going to be really, really similar to the previous formula. Okay, if this is a quarter of the circle, well, if I know that the whole area, which is pi r squared, if I figure out the whole area, I can just divide this by 4 to get just this piece right here. Okay, so that's what this means again. So to find the area of a sector, find the area of the whole circle, and then multiply it by, well, if I only want a fourth, multiply it by a fourth. If I just want half the circle, you cut it in half. If I want a tenth of the circle, multiply it by a tenth. Okay, and we'll do a practice problem like that in example 2 right here. Find the area of the sector formed by angle UTV. So there's the angle that I want. So I just want this portion of the pi. So if I just want this portion of the pi, that portion was 70 degrees. So out of the 360 degrees total, I'm just looking for this fraction's worth of my area. Remember, the area is pi r squared. So pi times my radius squared. Okay. So if I wanted the entire pi, it would be 64 pi. Play on words, that's what that's called. But I don't want all of this stuff because I'm trying to watch my weight. I just want this fraction's worth. Okay, this fraction can simplify into 7 over 36. And now actually if you want to just in your calculator do 7 divided by 36 times 64 times pi, you'll get an answer of 39.10, and that is in square inches. So just this portion right here would be 39.1. I don't want the area of the whole thing. I just want this much worth, 7/36 worth. Okay. So that's why it's very, very, very similar to what we did earlier. We'll do one more example together, and then I will be done. This question, once again, is a good one. Hint, 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 hint. You will see questions like this frequently throughout this unit, so we want to make sure that we know how to do it and do it well. Rectangular wall has an entrance cut into it. You want to paint the wall. So what you're trying to paint is you're just painting this part right here. Okay, because this is the door. You're not going to paint the door. You're just painting this part. So you're trying to figure out how much paint do I need to buy to be able to cover up this region. So you want to know the area of this region so you can determine how much paint you need. So notice that the area of the wall, A sub W, is really just this part right here, this outer rectangular part. Okay. But then you have to subtract off the area of the door. So it's the whole wall minus the area of the door. All right. So if I can figure out the area of this whole thing and subtract the area of the door, so that's what we'll do. So first, to find the area of this rectangular part, okay, notice this length right here is a 10 and a 16. So 10 and 16 is 26. And the length is 36. So the area of the rectangle is this times this. This part is 36. This length is a 10 and a 16, which make 26. So the area of that rectangle, if I do 26 times 36, that's 936 square feet. So if I was going to include the door with my painting, it would be 936 square feet. But I'm not painting the door. I need to subtract off the area of the door. And whatever I'm left with in this 936 is what I'm going to paint. Okay. Now, notice the area of the door. The area of the door is made up of a rectangle and half of a circle. So you're going to find the area of the rectangle and add it to the area of a half circle. Okay, well, the area of a circle is pi r squared. But then if it's a half circle, you want to cut it in half. All right, and then you'll add that to the area of this rectangular piece right here. And actually, it's a square because this is 16. This height right here is 16. So that square is a 16 by 16 square. So the area of the whole door is this half circle plus the area of the square, which is 60. Okay. So then let's figure that out. You good? You have a question?
No, I'm all set.
All right, you can sit on the table.
Can I say hi to the...
You can. Keaton Campbell, ladies and gentlemen.
Right here?
You can just talk. It'll pick you up. You
Hello.
can just say hi. You want to put your hand in too?
Yeah.
That's Keaton Campbell right there. All right. Thank you, sir. Appreciate it.
There's your cock header.
Thank you. Thank you.
You want none of this for next?
Yeah, I got you.
Actually-
We'll put it in a safe spot. I'll be right here waiting for you. Okay.
If anybody touches it...
All right. They got to deal with the wrath of Keaton Campbell. I don't want to experience that. See ya. Okay. So then here's the area of the square plus the area of the half circle. So the radius of this half circle, okay, is we're going to use this distance right here. It tells me that the radius, this distance right here is going to be, half of the diameter. If the diameter is 16, then the radius is 8. Okay, so the radius is 8, so I can put 8 in for R right here. 16 times 16 is 256. So then on your calculator, if you want to type all of this in, since I'm running out of room, 8 squared times pi divided by 2, and then add 256. So there's a lot to put in your calculator there. So I actually want you to try it. 8 squared times pi divided by 2 and then add 256. When you do all of this, confirm that you can get 356.5. Okay, so the area of the door, if you do it correctly, you should get 356.5. And then now we don't want the area of the door, we want the area of this extra stuff. So we'll take the area of the wall minus that area of the door, so 936 minus this 356.5 number, and you get roughly 579 square feet, because we're rounding to the nearest foot. So roughly 579 square feet. Okay, so there's going to be a lot of that where you have two different things and you have to either add or subtract the areas. Like in this one right here, you find the area of the triangle plus the area of the semicircle, right? So you find the area of a semicircle and add it to the area of a triangle to get the total area. So there's going to be a lot of that you'll be working with, but we'll practice that up and we should be all set. So thank you for watching. Have a wonderful day.